Hi, I'm Paul Battaglia, and this is section 12.1, Introduction to Limits. One of the things I have to make sure my students understand by the time we get to the end of section 12.1 is the answer to this question. What is a limit? So it's a very, very difficult concept because students have never seen it before and it's highly theoretical. So the way I start the lesson is I actually bring in a tube of toothpaste. And so what I do is I casually go up to a student and it's already been squeezed out a lot, and I just go up to them and I say, do me a favor, just squeeze the rest of this out for me, please. And so they do their best, and then I might pick it up again and I might actually give it to another student and say, would you just mind finishing it? There's still a little bit left. So we let the student do that, and maybe I even do it one more time. And then I come up to the class and I hold the toothpaste up and I say, what do we know about this? And hopefully somebody says, well, it looks like there's none left. Or maybe somebody says, there might still be some in there. And so my question then is, okay, well, is it really ever possible to get all of the toothpaste out of this tube? And so theoretically, the answer probably is no. I mean, it would take a Herculean effort probably to do it. So in order to kind of tease the idea of a limit, I tell them, well, there are some things that mathematically we don't necessarily need to know exactly where something is. Maybe just approaching it is good enough for what we want. So I have Gabe and Brittany here with me today, and they're going to talk to us a little bit about the approach we want to take from the teacher's perspective as we get ready to talk about limits. So Gabe, why don't you go ahead and start?
Sure. So the book tends to have a lot of focus towards the numeric approach to evaluating limits.
Okay.
So they like to set this up through tables and having students evaluate functions at values a little less than and a little bit greater than whatever x value the limit may be approaching. But along with that, I wouldn't forego having students maybe look at graphs.
Yeah, that's a good
So
idea.
have students draw the graphs of certain functions, and maybe once they figure out which x value they want their limit to be approaching, they could trace it with their fingers. And what I like to emphasize here is that as they're tracing, they're not at a single x value. They're actually, they're not at a single point or a single y coordinate. So they're actually approaching some y coordinate. And then maybe as their fingers are touching each other, they're not actually on the point on the graph. They're very close to it. And that's what I really like to emphasize about this limit, because they get confused between the function value and the limit. And that's what this emphasizes.
And I think alongside of that is a lot of times students leave this section and they think to themselves, okay, well, I guess this is really only useful for times when maybe my fingers won't meet, and where a limit might not exist. And so speaking of that, Brittany, which kind of cases do we want students to really look at?
All right, so in my class, I give many examples to students where the limit doesn't exist.
Okay.
So when the left and the right limits do not equal each other.
Correct.
And then also when it's oscillating, and then if it's unbounded.
Right, so these are all very important cases for students to understand as we move forward. I hope these tips have been helpful for you. Now you have much success in section 12.1.